Alright, so get ready. We're going to start adding and subtracting, working on these inequalities here. Your learning target is I can solve one-step inequalities by adding or subtracting. We're just focusing on the addition or subtraction types of problems today. Alright. So to actually go ahead and solve one-step addition or subtraction inequalities, this is the key concept. To solve these addition or subtraction inequalities, you can treat it in the same way that you would treat a one-step equation. Okay, it's the same type of thing. You can treat it in the same type of a way. To solve one-step addition or subtraction inequalities, we must first use the inverse operation. Okay, remember we talked about inverse operation a little bit ago. An inverse operation, what that is that's the term that uses to do the opposite of whatever you have. So the opposite of addition is subtraction, the opposite of multiplication is division. Okay, so we can use this inverse operation to undo whatever is being added or subtracted to the variable. So if it's being added, we subtract. If it's being subtracted, then we add. Okay. The second step after you use that inverse operation is that whatever you do to the one side, you have to do to the other. Okay. Whatever you do to the one side of the inequality, that less than greater than sign, you have to also do to the other side. We have to keep that whatever is there, we have to keep it balanced. All right. And then the third is actually graph. We're supposed to graph the set of solutions that will make the inequality true. That's not for every single problem, but especially the ones that it does ask you to do it for, you're going to want to do that. So example 1 says to solve the inequality 0.9 is greater than or equal to n minus 0.3, and then graph the solution. So first let's go ahead and solve this inequality, and we see that the number that is next to the variable is a subtracting 0.3 next to the variable. We want to get the variable by itself, so we're going to do the inverse operation of subtraction, which is just addition. So we're going to add 0.3. And remember, anything that we do to one side, we also have to do to the other. That's that second step that we were talking about. And so we're going to add 0.3 to both sides. Now what happens here, just like when we were solving one-step equations, is that's going to cancel out. We'll be left with just n. And n is less than 0.9 plus 0.3 is 1.2. Okay, so that is how you actually go about solving those inequalities. Now remember the step 3 there that we talked about, because it asks us to graph it, we need to make sure we graph it. So I just went ahead and built a number line. You'll probably want to do the exact same thing. But remember, to graph an inequality, we first have to put a dot at where the numerical value is, and that's 1.2. And we're going to close that dot in because it tells us that it is equal to as well. It is greater than or equal to, so we have to keep that equal to. And then we just got to test values, right? If we were to have n be 1.3, is 1.3 less than 1.2? Well, no, 1.3 is greater than 1.2, so we would not shade in that direction. Same goes for, we can use 1.1 or 1. Is 1 less than 1.2? We see that that is true, so we're gonna go ahead and shade off to the left. Like that. And that's your answer. Alright, example 2 says that Josh can bench press 220 pounds. He wants to bench press at least 250 pounds. We need to write and solve an inequality to determine how many more pounds Josh must lift to reach his goal, and then check your answer. Okay, so what I did is I made a couple of steps to be able to solve this equation. So let's kind of work through it. And the first thing we need to answer is the question, what do we need to know? And that part right there is it's written right here. Determine how many more pounds. So the question we need to find out, or what do we need to find out, is how many more pounds Josh must lift. Okay, and so if we go back and let's underline some of the important parts. We know that right now he can bench press 220 pounds, and he wants to bench press at least 250 pounds. Okay, so we've underlined those important pieces of information. We know that the variable that we need to use is kind of this missing information, is how many more pounds Josh must lift. So we're going to say P, we're going to say that's equal to the additional number of pounds. The additional number of pounds that he needs to be able to lift to meet his goal. Okay, and then now this fourth step is to actually write the inequality. I'm going to move this down just a little bit. I actually need to write the inequality here. And we know that right now he does bench press 220. And if we add that to the additional number of pounds that he needs to be able to lift, we know that needs to be greater than or equal to 250. And remember, and it can be equal to because 250 is that highest point. It can be 250. It can include 250. So now all we have to do is just solve that, right? So 220, I'm going to rewrite the inequality. Greater than or equal to 250. And we see here that this is a positive 220, and we need to get rid of that positive 220. So we're going to subtract. That's the inverse operation, is to subtract 220 from both sides. And we end up getting P is greater than or equal to 30 pounds. Okay? And then there's one last step in order to solve this, and I'm going to move it down once again. The last step that we have here is to check our work. Does this make sense? So if we plug 30 back into our equation, in for P, is that going to give us a value that is greater than or equal to 250? And 220 plus 30, well, that's 250, and that is equal to 250. Okay, so that does work out. That would meet his goal. Let's say that Josh instead, the additional number of pounds he's able to lift is 40. Okay, we want to check it with two different values, one that is the exact value and one that is more, or sets that equal to, right? Let's say it's 40. If we were to add this, 220 plus 40 is 260 pounds. That is greater than 250 pounds, so that makes sense as well. Okay, that's all we're doing for today. Hope you enjoyed, and good luck.